Okay, let's have a go at question 8 and probably question 9. Okay, I don't know if I can scroll that. I'll scroll down to number 9 in a minute. Okay, circular queue. So 2 algorithms needed: joining an item in a queue, so joining a queue, and removing. So let's have a look at joining. Couple of things just to be aware of. We've got a queue with 8 spaces. Okay, and it's a 0 reference list or array, and we'll make use of that because we can make use of the mod function. So we've got 8 positions in here, and we can use mod to do a wrap for us. Okay, so we'll look at that in a minute. Right, what we're going to do with this queue is we're going to keep a count. So there's going to be a count value that keeps count of how many items are actually in the queue. Okay, and we must always test if we're going to add something to a queue and make sure that the queue's got space. Okay, so the first part of the algorithm is just to do that test. Say, okay, is there any space? Are there less than 8 items in the queue? If there are, we're okay. If they're not, we output an error message. That's not very practical. You wouldn't output an error message. You'd have a function that returns a boolean that'd say, oh, you either successfully added something to a queue or you didn't. And you would leave it up to the caller of the function to determine what to do next if they couldn't be added to the queue. Okay, but as far as presenting just the algorithmic structure of it, that's all we're expected to do for the exam board. Okay, so let's assume we've got this set up where we've got 4 items in our queue. Let's put count in there. Oh dear, I'm not very good at drawing with this. Count equals 4. Okay, so the first if we say, okay, that's fine. Alright, then we say, right, okay, let's store our items straight away. Now, the nature of how I've organised this is that my end position is always pointing to the free space. Okay, so it's currently pointing to 5, so there's a free space there. So we can straight away put our data item. Let's say we're adding, I don't know, P. Okay, to this. So we just put our P straight in there. We then update our pointers, so we increase the end value by 1. So we say n plus 1, which will give us 6. And then we do mod 8. So 6 mod 8 is actually 6. Okay, so n becomes 6. So I'm just going to cross through, if it'll let me cross through that, and change n to 6. We're then going to increase the count, so we're going to say, cross out that, counter becomes 5. There are 5 items. Okay, we'll see how this mod works. So let's add a couple more items. So if I add 2 more items, so I'll get x, and then end will be 7, and count will be 6. Okay, if I now go to add a new item, so let's add y. So with the count's okay, so we're going to add a y in at whatever the value of 7 is, wherever that position is. Then we'll do this bit, so we'll end up with 7 plus 1, so we're doing this line. Okay, so 7 plus 1 is 8. 8 mod 8 is 0. So what end becomes is automatically wrapped using the mod function. Very useful, the mod function. So the next free space is there. Okay, count gets increased up to 7. Okay, and obviously if we add another item, that'll be the queue full. Okay, so that's adding to a queue. Now let's look at removing. Alright, I'll just quickly draw another little queue. It's got to have 8 items in it again. If we don't have a 0 based array, what you can do is you can do an if. So you just add 1 to front and then say if. So we'll do it on this one. I'll do it on this one to show you. So instead of using mod, so even though I've got that algorithm, let me just put these on top. Not very well divided up. So we've got 8 spaces. Okay. So if we had some items, let's have a G and I'll leave it as an I. Since it's had that. A G and an I. So front is pointing to 7. End is pointing to 1. Count, I'm just going to put a C, is 2. Okay, so again, the way the algorithm works, we want to remove, this is a function because we need to return a value. So we're going to check to make sure we've got something in the queue. If the queue is empty, so it is 0, it's not greater than 0, the count value, then we need to produce an error message. Okay, and because we've written a function here, I'm going to return null, so return nothing. Again, this isn't how you'd actually do it in practice, but it is just an algorithm to illustrate the process. Okay, so let's assume we've got a queue, so we have got a count of 2, so we're okay here. So we're going to retrieve the item that's at the front, so that's at position 7. Okay, now I'm not going to delete anything, but item is now, I'll just put an I in here to say what it is equal to, so that is now G. Okay, we're then going to move the front pointer, so we say front plus 1. Now that was if we was doing the 0 one, so let's ignore that for a minute. So we're just going to add 1 to front, so front is pointing at 8. Okay, let's remove another item, so we take the count down on this line, so that's now 1. Okay, the end pointer's not moved, we're not messing about with the end pointer. You'll notice that on the adding something to a queue, we didn't mess about with the front pointer. Okay, they look pretty similar really, adding and removing, especially in the circular, because you're chasing the same direction with the pointers. You're moving along the queue each time. Okay, so if we're moving the right item, counts 1, so we get into in here. So I becomes weirdly I. So let's cross G out. So I is I, because that's what's at the front position. Now we're going to add 1 onto front, so it's now going to be 9. So if we didn't use mod, because we weren't using a 0-based array, we could do this bit. So just cross that out. Then on this line here, what we'd have to do is just say if front, let me do that one. If front, this isn't easy. I should learn how to use a typewriter in this. If it's greater than 8, then what we can do is just say, okay, push front back to 1. So front equals 1. But that's why things are 0-based. It makes mod really, really useful, because mod's sort of doing that for us, but in a calculation way. So it's not there's no decision and then a bit of code to skip. Okay, so we can use mod on 0-based arrays. Your 0-based arrays do help us quite a lot. Okay, so you would do that instead. You could say, alright, if the point has gone beyond the maximum value for the array, go back to the start of the array. Okay, that's all we do instead. But we haven't got that. But that's the structure. If you can remember one of them, okay, then you can apply the logic of one to generate the other one. So you can see. So let's just get rid of all that cat. So the only bit that's different is we're returning an item, but the other structure is exactly the same. We mess about with our items. So if we look at the join one again, we use end to specify where we're storing something, move end across, update the counter. If you look at the remove one, we use front to specify the position we're retrieving from, move front across, update the counter. So the logic is the same in both removing and adding to a queue. Okay, it's the circular bit that you've got to remember. You can, and you will find in the exam board answers that they'll say a queue is empty if front and end point to the same location. So if we're saying end is pointing here, and that is also the front of the queue, then it's empty. But actually it could be full as well, because if I fill up this one at the top, let's put another, I'm not sure, put in there T, front points there, but end would automatically, using this algorithm, be pointing to the next location. Okay, so you wouldn't know from that whether the queue was full or not, so you do need to keep a count of how many items are in there. Okay, circular queues.